Hello friends, welcome to this video on number system. In the previous video, we learned how to represent rational and irrational numbers on a number line. Today we will be solving some questions based on it. Let's start with our first question. Represent the following numbers on the number line. The first number is minus 6.421. This is a terminating decimal. Friends, don't get confused seeing the negative sign. This number will lie between minus 6 and minus 7 on the number line. We will represent this number using the process of successive magnification like this. Now the number will lie between minus 6.42 and minus 6.43. Here. Friends, the second number is 8.34 bar. And according to the question, we have to represent it up to 4 decimals on the number line. This is a non-terminating recurring decimal. Will we be using the same process of successive magnification here? Yes. Please try to solve this question on your own. This number will lie between 8.3434 and 8.3435 on the number line. Now let's take another question. Can you represent root 3 and root 5 on the number line? In our previous video, we learned how to represent root 2 on a number line. Following the same method, let's see how to represent root 3 and root 5 on the number line. Here, point E represents root 2. We will now construct a perpendicular on line AC. Now measure the distance of 1 unit using a compass and draw an arc from point C on the perpendicular which cuts it at point F. Now draw a line joining center point A and point F. Friends, if you look carefully, here we are getting a right angle triangle ACF. Your length of AC is root 2 and that of CF is 1. Using Pythagoras theorem, we can find the length of AF, which will be root 3. Now measure the length AF using a compass and taking center as point A. Draw an arc on the number line which cuts it at point G, and this point G represents root 3. Friends, we can represent root 4 using the same process. And now we get the arc cutting at point 2. This is because the value of root 4 is 2. Now to represent root 5 on the number line, we will draw a perpendicular on the line AH and measure a distance of 1 unit using a compass and draw an arc on the perpendicular which cuts at point J. Now, draw a line joining point A and J. We get a right angle triangle AHJ. In triangle AHJ using Pythagoras theorem, we will get AJ as root 5. Measure the length AJ using a compass and keeping A as center, draw an arc on the number line which cuts it at point K. Point K represents root 5 on the number line. The formation obtained as a result of this process is called the square root spiral. Friends, till now we represented numbers which were in the form of root n, where n is a positive integer. But can we represent root a, where a is a positive real number on the number line? Yes, we can. Let's take an example for the same. Represent root 4.5 on the number line. Let's see how to do the same. On a line, take point A and B such that the distance between points A and B is 4.5 units. Now, from point B at a distance of 1 unit, mark a point C on the number line. Now find the midpoint of line AC, which will be AB plus BC divided by 2. Here we get O. Now taking O as the center, draw a semicircle using a compass. Draw a perpendicular from line AC at point B, which would cut the semicircle at point D. On joining O and D, we will get a right-angled triangle OBD. We know the length of AB is 4.5 and OA is 2.75. We will get OB as 1.75. In triangle OBD, on applying the Pythagoras theorem, we can find the length of BD. We will get BD as root 4.5. To represent this on the number line, we consider point B as 0 and point C as 1, and by taking the radius as BD, we will draw an arc on the number line like this. This point on the number line will represent root 4.5. In this way, we can represent any positive real number on the number line. That is it for today. In this video, we solved a few problems related to the representation of rational and irrational numbers on the number line. We will meet you in our next video with some facts related to this. Thank you.